welcome everyone in this lecture of week 8, where we will talk about the solution of the assignment of this particular week we have discussed about. So, in the last lecture we talked about we can read the stationary and non-stationary, which we have already covered in the previous tutorial. In this lecture, in this particular tutorial session, we will primarily focus on develop the one simple forecasting model using the some sort of time series data set. So, in the previous tutorial we have already talked about what is the time series data. Suppose this is your let us say x and y axis. So, here let us say you are plotting some sort of extreme rainfall data, which is I am saying let us say y can be your rainfall extreme, or let us say it can be your flood, or it can be your drought intensity, drought magnitude, like that. And then we have let us say this is your x axis. So, here we are plotting the time series data set. So, what is time series data set? For each different time step we have one single value. So, each different time steps can be, let us say it could be your month. So, for month you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then we have 11, then you have 12, and then again for next year you have 1, 2, 3, 4, like that. Or it could be your year as well, where you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, that represent the year, which can be 2001, 2002, 2003, 2004, like that. Or maybe it can be days also, where you are talking about daily rainfall extremes, or daily flow conditions, or daily temperature data set. It can be also that is. So, for example, if you are talking about rainfall extremes, we say that we have collected the data set for 365 days, and out of these 365 days we are calculating what is the maximum value, that is the block maxima approach. So, that is the block maxima approach we are talking about. So, that is the block maxima approach we are talking about, when we are selecting the data set for 365 and then we are calculating the block maxima. So, so the time series data set can behave something or something like that. For we have different time period, we have different value of y, which is extreme temperature, rainfall, or any climate extremes like that. So, over the time this is your let us say mean of the data set, and over the time this is mean behavior of data set, temporal mean, and how that temporal mean around that particular data set are behaving. So, that is basically called the time series. Here we have for each different time stamp we have one value, and that is basically we are plotting in some sort of, it can be also be tabulated in a particular Excel or some sort of table, where you have let us say year value, and then for example let us say 2001, 2002, or 2003, or 2004, and then you have certain values, let us say 100 mm, 150 mm, or 170 mm, or let us say 180 mm, like that. So, this is how basically we can categorize, this is your the time series data set. And then we have in the previous class we have also talked about what is the stationarity and non-stationarity conditions. So, what is stationarity? When we are talking about let us say this is one time series data set, and let us say it is like this in your and this is let us say t. So, if you take this part, or this part of the data set and calculate mean, standard deviation, or multiple other property of the distributions could be kurtosis or skewness, and similarly you calculate all these variable for this particular time series and then this particular time series, and then you compare all these statistical property. When you compare this, if there is no significant can changes, then that changes, that is basically we called. So, if there is no significant changes, that is we called stationary, that is we called stationary data, and if there is significant changes in the time series or the properties, that is we called non-stationary data set. So, suppose you have collected the rainfall data for this is let us say 10 years, then another 10 years, then another 10 years, and then you calculate what is the mean, standard deviation, kurtosis, skewness, again you calculate for next 10 years, then next 10 years, and then you compare. If there is no significant change, then we call is a stationary data. If there is a significant change, then we call the data has been changed, that is could be non-stationary. How the non-stationary data set is behaving? So, for example, this is your time series data, let us say this is y, this is x, and it could be your non-stationary data can be looking like either a continuously increasing trend, or let us say it could be like this decreasing trend, or it could be something like this also can be, where you have this is x value, this is y value, or there was something like this and suddenly there is a jump and something like this. So, here if you can see there is this is mu 1 and here is this is mu 2, and there is a significant difference between mu 1 and mu 2. Similarly, if it is sigma 1 and sigma 2, might be there is a significant difference between sigma 1 and sigma 2. That is basically we corroborate that this is a kind of a non-stationary conditions. So, this is we have already discussed in the previous tutorial in a very detailed manner. In this lecture we will, in this tutorial we will basically talk about how we can use a simple time series data set for predictions or for forecasting. So, suppose why we need forecasting, why we wanted to do forecasting. Let us say we have data set from 1970, okay, and then that is another data, let us say till 2010, and we do not know what will happen after 2040 or 50. We wanted to know what is likely to happen, how our time series data set will likely to behave in the future conditions. So, let us say this is 2025 and we are interested in after 25 years data set. How we can do that? We have the data set for this particular period, that is we called historical data set. So, for this particular data set we fit the forecast model and we use this forecast model to predict for next 25 years. Next 25 years, what is likely to be our time series behavior. So, how we do that basically? So, for example, let us talk about there is a data set where we have collected the historical part, that is x1, then you have x2, then you have x3, then you have let us say xt minus 2, you have xt minus 1, and then you have, let us say, xt. So, this is basically you have the data set. So, you use that data set for training the forecast model, and then you calculate what is the accuracy of the a particular forecast model. How do we do that? So, let us say you have data set till here, you wanted to do that forecast t plus 1, then you wanted to forecast t plus 2, t plus 3. That is your, let us say you kept these numbers not revealed, or let us say this is the test data for the forecast model. You kept this number in a such a way that you want to try or calibrate your forecast model, and then basically you compared your forecasted value. Let us say f t plus 1, f t plus 1 f t plus 2 and f t plus 3. So, this is basically you compare and then you calculated what is the forecast error of model. So, this is basically we can use these forecasting techniques to do these type of analysis. So, let us take a simple example, okay, to developing a simple moving average based forecast model. So, let us say you have time series data set. The data set is like 100, 115, 103, 108, 120, 97, 110, 121, 117 and 79. So, this is, let us say, your time series data set. Now, you wanted to do some sort of forecasting using moving average based model, okay, simple moving average based model. So, let us say in this case we are using a 2-step moving average, or window size is 2, which means let us say this is 2 value, okay, this is another 2, this is another 2, like that. For this 2 value, what would be the let us say this is 105. So, what would be the forecasted or average value? So, 105 plus 115 divided by 2, that is 10, 2 and 2, right, divided by 2, that is coming out to be 110. So, here the average value of between these two values are 110. That is the forecasted value for this particular step. Now, you use this particular again 115, 103 for forecasting 105 or particular values. No, this is basically for forecasting for this particular 103 and 110. Now, you can take again this particular set 115 plus 103 and divided by 2, that is your 8, 1, 2 and 2, that is coming out to be 109. So, let us say this is 103, so 538, this is 1 and 2, that is coming out to be 109. So, let us say if you have done this, that is your 109 and you are comparing with this particular forecasted value. Then you can take another step 103, 108, that is basically 11, that is coming out to be 211, and 211 divided by 2, that is 1.5, right, 1.05.5, that is 210 or 211. So, then you have another forecasted value, that is 105.5, that you can compare with 120. So, now you can calculate what is the error in the forecasts. So, similarly you can do this analysis for this 2, this 2, this 2, this 2, and like this. And let us say what is the error in this particular forecast, you can calculate 115 minus 110, sorry 103 minus 110, that is coming out to be minus 7. Then you can calculate the error between 109 or 108 minus 109, that is coming out to be minus 1. Then you can calculate the error in your data set, that is 120 minus 105.5, that is coming out to be 14.5 minus, no, plus. So, this is basically how we can calculate the forecasted value. Now, how we can calculate what is the next step after this? So, here let us say you have this value, you can calculate 117 plus 79 divided by 2, that is coming out to be some number, and that would be your forecasted value. Now, you can use x t plus 1, you can use x t plus 1 plus 79 value and take the average of this, that would be your x t plus 2, that is your another forecasted value. Now, you can use x t plus 1 plus x t plus 2 divided by 2, that is your another forecasted value x t plus 3. So, this is how basically you can use the simple moving average technique to do the forecasting of your model based on your time series data set. Now, you can use let us say the similar technique for making different types of moving averages also. For example, let us say I am writing the data again 10 let us say 10 1 minute. So, let us say we are writing the data again, that is let us say 105, 115, then let us say 103, then let us say 108, let us say 120, let us say 120, then you have 97, then you have 110, then you have let us say 121, then you have let us say 117 and 79, like that. So, this is your time series data set for one climate extremes or one climate properties. How we can apply the moving average of 3. So, in the previous example we have talked about moving average of 2. Now, you can use this particular 3 values and then tell about a forecasted value f1, and then you compare this particular value with 108 and 10 this one. Now, you can use this particular 115, 103 and 108 and calculate 1 f2, and you can compare with 120. Then you can take 103, 108 and 120 and calculate F3 and you can compare with 97. They can take another 108, then 120 and 97, calculate F3, F4 and then this is how basically you can apply the moving average of 3. Here you think here what we are doing, we have increased the moving average window. Now this is here we are using 3 window. In the previous example we were selecting the 2 windows like this, then this, then this, then this, but here we are using 3 values at the time. It can be also possible you can use moving average of 3 cross 3 window. How we can do that? So let us say this is your original data x1, x2, x3, x4, x5, x6, x7, x8 like that. So you have taken these 3 and calculated the F1. Then you have used these 3, calculated F2. You have used these 3 and calculated F3, and you have used these 3, you calculated F4. You have used these 3, calculated F5 like that. Then you basically calculate the average of these and calculate, let us say Z1, calculate the moving average of this is Z2 and calculate the moving average, this is Z3. So this is basically called moving average of moving average, and that can be done by applying the 3 cross 3 window size. Here we are using the 3 window size to calculate the moving average of and then using this moving average we are trying to forecast the time series behavior. So what is the major limitation of this? Is very simple forecasting model, of course. The major thing is it will always create or forecast the data near your average values, which means if you apply these types of algorithms, your extreme nature of behavior of time series might change. So that will change, and that basically give you the average behavior of the data set. So that is basically you can use these kind of simple moving average based model to do that analysis for simple example data set. You can perform this analysis using some sort of Excel, and using that Excel you can basically do moving average based analysis for any particular climatic streams. So this is the solution of this week 8. You can try this type of very simple forecasting model using MATLAB, Python or Excel. You can use different moving average or window size, and you can also try to plot these data set in Excel or Python or MATLAB, and then you can look at it how the forecasted values are changing the behavior of the time series, or whether it is very close to the average value, it has been removed the very extreme values from the data. Similarly, on this concept we will also develop some sort of more advanced forecasting models, for example ARIMA type model. We will discuss about those advanced model in the next tutorial. This is for the today's tutorial. We will talk about more in detail in the next lecture and also in the next week as well. Thank you so much.